Here we are solving October 2023 Pure Math 4 paper. In the previous two videos we covered question number 1 to 6. Let's look at question number 7. The number of goats on an island is being monitored. When monitoring began, there were 3000 goats on the island. Okay, so when time is 0, t is the time, number of years after monitoring began. X is the number of goats in 1000, so X was 3000. In a simple model, the number of goats X in thousands is modeled by this equation, where K is a constant, T is the number of years after monitoring began. Show that K is 1.8, just sub in here. But you need to sub in X by 3, not 3000. So you will get 3 is equal to K be T, replace T by 0. So you will get, you can just write T is equal to 0, X is equal to 3 implies 5K over 3. So you'll get K is 9 over 5. K is equal to 1.8. It's a 2-mark question. Let's move on to part B. Hence, calculate the long-term population of goats predicted by this model. The model is X is equal to K times 90 plus 5 divided by 40 plus 3. 40 plus 3. It's a 1-mark question. I want you guys to listen to me. Whenever the question talks about long-term population or the upper limit or the maximum value that the X can reach and all, it's going to be a 1-mark question. But the proper way of doing it, you have to replace T by infinity to get the value. Well, you cannot replace T by infinity, so everything becomes infinity over infinity here. But at the same time, if you have 1 over T, when T tends to infinity, 1 over infinity tends to 0. So you need to have 1 over T before replace T by infinity. So to get 1 over T, what I'm going to do, I'm going to take T as a common factor out. So we'll get 9 plus 5 over T divided by 4 plus 3 over T. T can be cancelled. So this is a proper way of finding it. Now T tends to infinity. X tends to, if you replace T by infinity, this becomes 0. 1 over infinity, this becomes 0. So you will get 9 times 1.8 divided by 4. 9 times 1.8 divided by 4. That's the value of X, but you need to multiply by 1000 because X is given in 1000. You get X is equal to, X tends to 4050. So when T approaches a very large value, that means infinity, X will approach 4050. That's the maximum value. So this is a proper way of finding the maximum value, the upper limit. Once you practice, though it's a 1-mark question, you might be thinking that there are a lot of working, but once you practice, 10 seconds is all you need. I'm going to move on to part C now. In a second model, the number of goats X in thousands is modeled by this differential equation. Okay, write X3 over this in partial form, partial fraction form. So you take it as 3 over X times 9 minus 2X. It's a proper fraction, so you can just write A over X plus B over 9 minus 2X. Multiply throughout by denominator, you'll get 3 is equal to A times 9 over 2X plus B times X. When you replace X by 0 on both sides, this becomes 0, this becomes 0. 9A is equal to 3. So A is equal to 1 over 3. And then you can sub in some other value for X to find B. I'm going to replace X by 1 now. So I will get 3 is equal to 9 minus 2, 7A plus B. So B is equal to 3 minus 7A, which is 9 minus 7, 2 over 3. Once you got the values, you need to put the values back in here and write it as a partial fraction. So it's going to be 1 over 3. A is 1 over 3. So you need to write it as 1 over 3x. You need to write this extra step at the end. B is 2 over 3. So you write it as 2 over 3 times this. That's all. Part D now. Solve this differential equation with the initial conditions. Initial condition to show that x is equal to this. Which differential equation? The differential equation given in the previous part. They want us to solve it. So the differential equation is x 3 dx by 3 dx over dt is equal to x times 9 minus 2x. So the method we are going to apply here is the basic method, separating the variables. You need to collect all the x's dx to one side of the equation, t and dt to other side. So you can put this x times 9 minus 2x here, dx is equal to, push the dt to the other side, and then you integrate both sides. How do we integrate this? Using partial fraction. So we are going to use the result from the previous part. It's going to be 1 over 3x. You can take the result from the previous part. 2 over 3 times 9 minus 2x dx is equal to, integral of dt is just t plus c. So how do we integrate the left hand side? Keep 1 over 3 as it is. Derivative of ln x, 1 over x is ln x. Sorry, integral of 1 over x is ln x. Plus 2 over 3. Integral of 1 over 9 minus 2x. You need to apply this rule. Integral of 1 over a linear function is ln modulus ax plus b divided by the coefficient of a plus c. So in this case, ln modulus 9 minus 2x divided by coefficient of x is negative 2. You don't need to put plus c both sides. One side you add plus c, that's enough. So that's all. We need to simplify this, make x as a subject. So we have this step. When we cancel 2, the plus into minus becomes minus. I'm going to multiply throughout by 3. So it becomes ln x minus ln modulus 9 minus 2x is equal to 3t plus 3c. I'm going to just keep it as c. 3c is also a constant. So I'm going to keep it as c. We need to prove that x is this actually. Now to find c, probably we can combine the logarithms. I'm gonna write it without the modulus because it's not a definite integral. We are not gonna sub in any value. We are gonna sub in a condition here actually. Just keep it as modulus as of now. 3t plus c. To find c, we use the initial condition from the model. Here the initial condition says t is 0, x is 3000. So t is equal to 0, x is equal to 3. Sub in here, you will get ln 3 over 9 minus 6 is also 3 is 0 plus c. So we will get ln 1. ln 1 is also 0. C is 0 actually. So sub in back in here. Now we can remove the modulus and write it this way. Is equal to 3t. So remove ln, it becomes 3x over, when you remove ln, it becomes x over 9 minus 2x is equal to e power 3t. But look at the answer we are trying to achieve. We need e power minus 3t, right? So probably we'll just make x as a subject, we'll get the answer. Probably I can flip both sides. 9 minus 2x divided by x is 1 over e power 3t, which is this. Bring the x here. 9 minus 2x is equal to x times e power minus 3t. Bring the 2x also here. So it's going to be 9 is equal to x times 2 plus e power minus 3t and then find x. You got the answer already. X is 9 over 2 plus e power minus 3t. That's all. So only thing you should remember here, when you integrate, you need to apply this rule. That's very important here. So that's all. Let's move on to the next part now. Again, they are talking about long-term population, the maximum limit, maximum value of x. We got the value of x as 9 over 2 plus e power minus 3t. Remember, e power infinity is equal to infinity. E power minus infinity is 0. Because if you look at the graph, when x goes to infinity, y goes to infinity. When x goes to minus infinity, y goes to 0. So how do we write this? To find the maximum limit or long-term population, you need to write t tends to infinity, x tends to 9 over 2 plus e power minus infinity is 0. 9 over 2 is 4.5 times 1000, so x tends to 4500. That's all. Question number 8. We have a figure given. Figure 3 shows a sketch of the curve with parametric equation. X is equal to this, y is equal to this, from t is equal to 0 to pi over 2. The curve is given from here to here. So the value of t corresponding to these two limits are 0 to pi over 2. Okay. Part A of the question says, the curve meets y-axis at 2, x-axis at k. Find the value of k. Apparently, this k, we need to find the value of k. At this point, the x coordinate is k, y coordinate is 0. But the value of t corresponding to this point is pi over 2. This. So sub in pi over 2 in here, replace x by k. So you will get k is equal to 6t minus 3 sine 2 pi over 2 is pi. Sine pi is 0, you will get 3 pi. So it's a 1 mark question. The value of k is equal to 3 pi. That's all. Let's move on to the next one. Find dy, use parametric differentiation to show that dy by dx is this. Okay. We'll take the x first. 6t minus 3 sine 2t. Differentiate it with respect to t. We'll get 6 minus 3 times derivative of sine 2t is 2 cos 2t, which is 6 minus, I'll take 6 as a common factor, 6 minus cos 2t. Take y is 2 cos t, differentiate it, you will get minus 2 sine t. Now use the parametric differentiation. Dy by dx is dy over dt divided by dx over dt, which is minus 2 sine t divided by 6 times 1 minus cos 2t. But we need this answer. That means some number divided by sine t. That's what we need. So let's write cos 2t using the double angle formula in terms of sine. We know cos 2t is equal to 1 minus 2 sine square t. So put the sine square here, cos here. 2 sine square t is equal to 1 minus cos 2t. So I'm going to replace the 1 minus cos 2t by 2 sine square. So it's going to be dy over dx is equal to minus 2 sine t divided by 6 times 2 sine square t. Cancel 2, cancel a sine t, you will get minus 1 over 6 sine t. So minus 1 over 6, 1 over sine t is cosecant 2t. So the answer is basically minus 1 over 6 cosecant t. That's the answer. Where lambda is, you don't need to separately write lambda, I'm just showing you. Lambda is minus 1 over 6. That's all. Part C. The point P with parameter t is equal to pi over 4 lies on C. The tangent to C at point P cuts the y-axis. The tangent to C is a straight line. The straight line cuts the y-axis. So if you know the equation of the straight line, to find the point n, the y-coordinate of n, you replace x by 0, right? If you know the equation of the tangent. So we need to find the equation of the tangent and replace x by 0. That's what we are going to do. So first, we need to find the point P using this. Submit this into both x and y. We have x is equal to 6t minus 3 sine 2t. Y is equal to 2 cos t. Replace t by pi over 4. You will get x is equal to 6 times pi over 4 is 3 pi over 2 minus 3 sine 2 times pi over 4 is pi over 2. So sine pi over 2 is 1. So you will get 3 pi over 2 minus 1. That's the x coordinate. Replace t by pi over 4 here. Y is going to be 2 cos pi over 4. Radian mode, 2 cos pi over 4 is just root 2. So the point P is basically x coordinate is this minus, not minus 1, minus 3 comma root 2. That's the point. And we have dy by dx. So you can find the slope now. Okay, I'm going to take the dy by dx from here. It's minus 1 over 6 cosecant t. Dy over dx is equal to minus 1 over 6 sine t. So the slope of the tangent is dy by dx at the point P. So you need to replace sine t by this. 3 pi over 2 minus 3 minus 1 over 6 sine, it's not x actually, it's t, and in the first part it says here it says t is pi over 4 at the point P. So you need to replace t by pi over 4. So it's basically minus 1 divided by 6 sine pi over 4 is minus root 2 over 6. We have the slope, we have the point. We can write the equation of the tangent as y minus y1, this is x1 y1, is equal to slope times x minus x1, x minus the x coordinate of the point. And before simplifying, what we are trying to do here, we are trying to find the y-intercept of this point. To find the y-intercept, you can straight away replace x by 0 and make y as a subject. So when you replace x by 0, x is equal to 0. You will get y minus root 2 is equal to, this becomes 0. So when you multiply these two, it becomes positive root 2 over 6 times, I'm going to combine it to a single fraction, 3 pi minus 6 divided by 2. Or we will keep it as it is because it's going to be a little trickier actually. By minus 3 multiply throughout by square root of 2 by 6. So y is, multiply these two, you'll get 3, 6 can be cancelled, so you'll get pi root of 2 divided by 4 minus root 2 by 2, and when you bring this also root 2 here, it becomes plus root 2. So that's pi root 2 divided by 4 minus, when you multiply and divide this by 2, so you can combine, you'll get plus root 2 by 2. That's the y coordinate of the tangent. Do not use your calculator completely. You will get a decimal number. You need to do it manually. Let's move on to part D. The region bounded by the curve x-axis and the y-axis is rotated through 2 pi radians about the x-axis. They are talking about this region. When you rotate this region about x-axis 2 pi radians, you will get this 3D shape. And we need to write the volume as an integral in this form and then integrate it, find the exact volume. Total of 6 marks for this question. So when you have parametric equations, the formula to find the volume is pi integral y square, in this case y of t square, t1 to t2, x dx is x dash of t, differentiate x and then dt. Here the t is 0 to pi over 2, so the volume is going to be pi integral 0 to pi over 2 y square, which is 4 cos square t, and then differentiate x, you will get 6 minus 6 cos 2t dt. So you can take 6 as a common factor out, times 4, it will come out as 24 pi integral 0 to pi over 2 cos square t times 1 minus cos 2t dt. We have taken this integral separately. We know this identity, cos 2t is equal to 1 minus 2 sine square t. If you rearrange, you will get 2 sine square t is equal to 1 minus cos 2t. So I'm going to replace this by 2 sine square. So the 2 I can put it outside, 48 pi integral 0 to pi over 2 cos square t sine square t dt. Cos square t sine square t. We have one more identity, sine 2x or sine 2t is 2 sine t cos t. Square both sides. Sine square 2t is equal to 4 sine square t cos square t. Divide by 4, you will get sine square 2t divided by 4 is sine square t cos square t. So what I'm going to do, I'm going to replace this by sine square 2t over 4. So I'm going to get integral 48 pi integral 0 to pi over 2 sine square 2t over 4 dt. If you cancel 4 and this, it will be 12. So we have 12 pi integral 0 to pi over 2 sine square 2t dt. But we need the answer in this form. So apply the identity again. We know cos 2t is 1 minus 2 sine square t. Rearrange, make sine square t as a subject. You will get 1 minus cos 2t divided by 2. But we need sine square 2t. So I'm going to replace t by 2t on both sides. So I will get sine square 2t is equal to 1 minus cos 2 times 2t, 4t divided by 2. That's what I'm going to sub in here. So I will get 12 pi integral 0 to pi over 2 1 minus cos 4t divided by 2 dt. Cancel this, you will get 6 pi. So you can write it in this form. It's going to be integral 0 to alpha, it says it's pi over 2 beta times, which is 6 pi times 1 minus cos 4t dt. That's all. So that's the answer for I. In double I, we need to find the exact volume. So we need to integrate it now. We need to integrate this. So when you integrate, first I'm going to write it as, probably I can keep 6 pi outside. Integral 0 to pi over 2 1 minus cos 4t dt. So 6 pi, 1 becomes t, cos 4t becomes sin 4t over 4, 0 to pi over 2. Replace t by the upper limit pi over 2, you will get pi over 2 minus sin 4 times pi over 2 is 2 pi by 4, that's upper limit, minus, replace t by 0, the lower limit 0, 0 minus sin 0 is also 0. What's the value of sin 2 pi? Sin 2 pi is also 0. You can use your calculator. Sin pi is 0, sin 2 pi is also 0. So this whole thing is 0. So you have 6 pi times pi over 2, you will get 3 pi square. That's all.